Here we have the ionic compounds of the alkali metals: lithium chloride, sodium chloride, potassium chloride, rubidium chloride, and cesium chloride. The question arises, which one of these is more ionic and which one is the least ionic compound? So let's come to that one. Here, cesium chloride is more ionic than rubidium chloride, than potassium chloride, than sodium chloride, than lithium chloride. That means here lithium chloride is the least ionic one, whereas cesium chloride is more ionic as compared to the other four. Now, why is this so? This can be explained based on the size of the cation. Here, the size of chlorine is the same, okay? For the anion, Cl minus, all are having the same size because same atom. But the size of cesium is more as compared to that of rubidium, that of potassium, that of sodium, and that of lithium. So that's why cesium chloride is more ionic than the other four chlorides. So let's come to that one. Lithium, sodium, potassium, rubidium, and cesium. As we move from top to bottom along the group 1, what happened to the size of the atom? It increases. Atomic size increases. So if the atomic size increases, what happened to the ionization enthalpy? Ionization enthalpy or ionization energy decreases. So if the ionization energy decreases as we move down the group, it means that cesium, which is having the larger size as compared to the other four, cesium is more reactive. That means it can easily lose its valence electron to give cesium plus. That's why, since the size of cesium is more as compared to the other four, then this cesium chloride, the bond between cesium and chlorine is large. If it is large, what happened? It is weak. That's why it can easily give CS plus and Cl minus, which shows the ionic character of Cl, of cesium chloride. Whereas lithium chloride, the size of lithium chloride is very small, okay? And then we have Cl. Now the bond here is smaller. If the bond is smaller, what happened to the strength of this bond? It is strong. So it is not easy to lose. This lithium has it is not easy to lose the valence electron which is present in this lithium, which is why this one is less ionic. Okay, lithium chloride is less ionic, whereas cesium chloride is what? More ionic. That's why in increasing order we have lithium chloride, sodium chloride, potassium chloride, rubidium chloride, and cesium chloride. This one is more ionic than rubidium chloride, than potassium chloride, than sodium chloride, than lithium chloride in terms of ionic character. This one is more ionic than rubidium chloride, and then rubidium chloride is more ionic than potassium chloride. Potassium chloride is more ionic than sodium chloride, and sodium chloride is more ionic than lithium chloride.